Look at the Earth beneath us. To the human eye, it seems permanent, solid, unmoving. But in East Africa, the ground is telling a different story. Cracks are appearing out of nowhere, deep, wide, and hungry. They aren't just surface scars, they are the physical manifestation of a continent literally being torn in two. For years, scientists have watched this stretch of land, the East African Rift, stretch by mere millimeters. But as they look deeper, they've realized something far more unsettling. The movement isn't just happening on the surface, it's being fueled by something monstrous hiding 1,500 kilometers beneath our feet. There is a force down there that defies our understanding of geology. Something so massive, it's rewriting the map of the world in real time. What if Africa is slowly tearing itself apart, and we're only just beginning to understand why? The East African Rift is not just a scar on the landscape, it is one of the most significant geological features on the planet. Spanning over 6,000 kilometers, this massive system of valleys stretches from the Afar region in the north all the way down through Ethiopia, Kenya, Tanzania, and into Mozambique. To look at it from a map is to see a continent that looks like it is unzipping itself. This is the front line of plate tectonics. Beneath our feet, the Earth's outer shell, the lithosphere, is not a single solid piece. It is broken into massive plates that are constantly in motion. In this region, Africa is pulling away from itself. We are witnessing the slow-motion birth of two distinct pieces, the Nubian plate to the west, which makes up the bulk of the continent, and the Somali plate to the east. It is a process that has been happening for millions of years, yet it remains almost invisible to the naked eye. The plates are separating at a rate of only 2 to 7 millimeters per year. To a human living on the surface, that speed is imperceptible. You could stand on the edge of the rift for an entire lifetime and never feel the ground move. But in the language of geology, this is a violent, high-speed collision of forces. The evidence is hidden in plain sight. If you travel through the Rift Valley, you see the terrain dropping away into massive, deep depressions. You see a chain of long, narrow lakes that look like dark blue ribbons carved into the earth. You see walls of rock that tower over the valley floor, marking the fault lines where the crust has literally snapped under the immense stress of being pulled apart. It's not just a valley, it's a graveyard of old landscapes and a workshop for new ones. You see it in the chains of volcanoes that line the rift, acting as pressure release valves for the tectonic stress below. Every earthquake that rattles the windows in Nairobi or Addis Ababa is a reminder that the tension is building. For a long time, we thought we understood why this was happening. We assumed it was just the standard dance of tectonic plates, the same process that creates mountain ranges and ocean basins elsewhere. But as our technology has improved, our questions have changed. We started to realize that the rifting here is far too intense, and the volcanic activity far too widespread to be explained by simple plate movement alone. The deeper we looked, the more it became clear that the surface of Africa is being manipulated by something much larger, something much more powerful, something buried deep within the Earth's mantle. The real mystery isn't just that the continent is splitting, it's that the continent might be losing its grip on the very foundation it rests upon.
To understand why Africa is splitting, we have to look past the surface and descend into the planet's interior. The Earth is structured like a massive layered engine. At the center, you have the inner and outer cores, where temperatures reach thousands of degrees. Surrounding that is the mantle, a vast, semi-solid layer of rock that, over millions of years, behaves like a slow-moving fluid. This brings us to a concept called mantle convection. Because the interior of the Earth is so much hotter than the crust, heat tries to escape. It rises in plumes, pushing toward the surface. When that heat hits the underside of a continent, it doesn't just pass through. It exerts immense pressure. It thins the crust, breaks it, and forces magma upward. For decades, scientists used seismic tomography to map what lies beneath the African continent. Think of this as a CAT scan for the planet. By analyzing how earthquake waves travel through the Earth, researchers can determine the density and temperature of the rock beneath them. What they discovered shocked the scientific community. They found something massive, a gargantuan, bulbous structure of hot, buoyant rock rising from the core mantle boundary. They called it the African superplume. This structure is staggering in scale. It rises nearly 1,500 kilometers from the depths, stretching thousands of kilometers across. It is effectively a giant, slow-motion blowtorch aimed directly at the heart of Africa. As this superheated material pushes against the bottom of the tectonic plate, it creates an enormous updoming effect. The crust is stretched, pulled thin, and eventually it fractures. That is exactly what we see in the Rift Valley today. But it's not just a passive force. This superplume is the engine of the region's intense volcanic activity. When you look at the landscape of the rift, you aren't just seeing a valley, you are seeing a network of arterial highways for magma. Take Ale in Ethiopia, a volcano that has hosted a persistent bubbling lake of lava for decades. Or Old Donyo Langai in Tanzania, which erupts a unique thin carbonated lava that flows like water. These aren't isolated incidents. They are the surface symptoms of that massive engine churning deep below. Now, there is a legitimate scientific debate happening right now about the mechanics of this. There are two primary theories. The first is that the superplume is the primary driver, that the sheer upward force of this mantle anomaly is what is physically prying the continent apart from the bottom up. The second theory argues that the plate movement is largely driven by the tension between the Nubian and Somali plates themselves, and that the plume is merely the secondary contributor, exacerbating the rift rather than initiating it. We are essentially watching a high-stakes tug-of-war. Is the continent splitting because the plates are pulling away, or because the ground beneath them is literally being pushed apart? Scientists are currently deploying vast networks of seismic sensors across the rift to capture the data needed to solve this. They are tracking the speed of the plates, the chemistry of the volcanic gases, and the exact path of the seismic waves through the mantle. Every new measurement adds a piece to the puzzle, but the overall picture is clear. The ground beneath Africa is not a static foundation. It is a dynamic, shifting, and deeply volatile environment. The mantle beneath us is alive with movement, and that movement is the architect of everything we see on the surface. We are witnessing the Earth in its most raw, unrefined state, a planet that is still in the process of building itself. And as we continue to investigate, we are beginning to realize that the history of this land is tied to something much older than humanity itself. The Rift Valley isn't just a place where the Earth breaks, it is a place where the history of our world, and perhaps our own existence, was written. Because as it turns out, the same forces tearing the continent apart are the very forces that created the conditions for human life to thrive.
The story of the East African Rift is not just about the cooling of mantle rock or the breaking of plates. It is the story of our own origins. For decades, paleoanthropologists have looked to the Rift Valley as the cradle of humanity. This isn't a coincidence. The very geological processes that tore the continent apart created a unique, high-pressure laboratory that forced our ancestors to evolve. Think about the environment of millions of years ago. Before the rifting, this region was largely a dense tropical forest. But as the tectonic plates pulled apart, the Earth began to sag, creating deep basins and rising mountains. These changes in elevation acted as a massive climate filter. The mountains blocked moisture from the oceans, turning the lush forests into a mosaic of woodland and vast open grasslands. Our ancestors, who were once comfortable in the trees, suddenly found themselves in a changing, unpredictable landscape. They had to adapt or vanish. The geological activity of the Rift Valley also created the perfect conditions for preserving our history. As the plates moved, they triggered volcanic eruptions, blanketing the landscape in layers of fine ash. This ash acts like a geological time capsule. It buries bone fragments, protects them from the elements, and most importantly, it provides a precise chemical signature that allows scientists to date these fossils with incredible accuracy. It is here, in the sediment of places like Ethiopia's Afar Triangle and the shores of Lake Turkana in Kenya, that we found Lucy, the iconic Australopithecus skeleton that changed our understanding of human movement. In the rift, we find a clear chronological sequence of fossils that track the transition from ape-like ancestors to early hominins. The environmental stress, the fragmentation of habitats, and the pressure of competing for resources in a shifting ecosystem essentially pushed early hominins toward bipedalism, tool use, and greater brain capacity. But this relationship between geology and humanity goes beyond ancient history.
Today, the Rift Valley is home to millions of people who live directly in the shadow of this tectonic drama. This land is a paradox of danger and abundance. The same faults that cause devastating earthquakes also provide the region with some of the most fertile volcanic soil on Earth. The geothermal activity that warns of volcanic eruptions is now being harnessed to power entire national grids with clean, renewable energy. The lakes that formed in the deep rift basins, like Lake Victoria and Lake Tanganyika, are not just beautiful landmarks, they are the primary water sources for millions. This geography has dictated human migration, agricultural practices, and cultural development for millennia. The rift created the stage, and humanity, in its own way, has been performing on it ever since. We often view ourselves as separate from the planet, as observers of a world that we simply inhabit. But the Rift Valley reminds us that we are a product of this planet's volatile nature. Every trait we possess, every survival instinct we have inherited, was sharpened by the very forces that are currently tearing the African continent in two. We are the children of a shifting, breaking, and restless Earth.
We are looking at a future that feels like science fiction, but it is written in the bedrock of our planet. The process we are witnessing, the slow, agonizing tearing of the African continent, is not a random event. It is the beginning of a cycle that has shaped our world for billions of years. If the rifting continues at its current steady pace, the East African Rift Valley will eventually drop low enough that it breaches the threshold of the sea. It will start in the north, where the Afar region is already dangerously close to sea level. Once that barrier is breached, the waters of the Red Sea and the Gulf of Aden will come rushing in. What is today a dry, rugged valley of volcanic rock will transform into a narrow, linear sea. Initially, it might resemble the Red Sea, a deep, confined stretch of water. But as the plates continue to diverge, the rift will widen, and the crust at the bottom of this new sea will thin and pull apart. Here, the process shifts into high gear. Molten rock from the mantle will rise, solidify, and create brand new oceanic crust. This is how ocean basins are born. It is the same tectonic rhythm that, millions of years ago, split the supercontinent of Pangaea and gave rise to the Atlantic Ocean. In 5 to 10 million years, the map of the world will look fundamentally different. Africa will no longer be one massive unified landmass. Instead, it will be severed into two distinct continents. To the west, the massive Nubian plate will hold the majority of the current continent. To the east, a new, smaller continent will drift away, carrying with it parts of Ethiopia, Kenya, Tanzania, and the entirety of present-day Somalia. Nations that were once landlocked, countries like Uganda, Zambia, and Rwanda, will suddenly find themselves with brand new coastlines. The geography of global trade, human settlement, and climate patterns will be permanently rewritten. But this revelation brings us back to the core truth of our planet. Continents are not permanent. They are not static platforms upon which history plays out. They are transient, drifting rafts, constantly being broken, recycled, and rearranged by the immense heat and pressure within the Earth. The split we see today is just one chapter in a much larger story of a planet that is perpetually evolving. The ground beneath our feet feels solid, reliable, and eternal, but it is a facade. Deep below, the Earth is rewriting the map of the world, 1 millimeter at a time. The continent may appear whole today, but the cracks are there, a reminder that in the grand cycle of our planet, everything is in motion, and everything is destined to change.
When we look up at the stars, we often think of space as the ultimate frontier, a vast, ever-changing void. But we tend to forget that the ground beneath our feet is just as dynamic. We walk on a planet that is literally alive, a complex, self-renewing machine that never stops building, breaking, and reinventing itself. The story of the East African Rift is not a story of destruction. It is a story of transformation. We are so accustomed to the static map of the world, the continents we learn in school, the borders drawn by ink on paper, the shorelines that have stayed the same for as long as we have been recording history. But that map is a snapshot in time. It is a momentary pause in a process that has been running for over 4 billion years. If we could speed up the clock, if we could compress millions of years into a single breathtaking time lapse, we would see the continents dancing. We would see land masses colliding to form massive mountain ranges, and we would see them pulling apart to birth new oceans. We are living in a brief window where Africa appears whole, but the geology tells us that this is only a chapter, not the final word. This realization changes how we see our own existence. We are a part of this geological pulse. The same forces that pushed up the mountains of the Rift Valley also provided the high-altitude environments that pushed our ancestors to stand upright. The same volcanic activity that presents a hazard to modern cities also provided the fertile soil that allowed civilizations to flourish. We are not just living on the Earth, we are an extension of its history. There is a profound humility in acknowledging this. We build our homes, our cities, and our infrastructures on foundations that are, on a planetary scale, remarkably fragile. We operate on a timeline of decades or centuries, while the Earth operates on a timeline of eons. Yet every earthquake, every tremor, and every volcanic eruption is a quiet, powerful reminder that the Earth is not merely a stage for our drama. It is the protagonist. The Rift Valley will keep widening. The magma will keep rising. The sea will eventually claim the lowlands of Ethiopia and Kenya. Long after our current civilizations have become little more than layers in the archaeological record, the planet will continue its work. The continent may appear solid beneath our feet today, steady and immovable, but deep below, in the dark, molten heart of our world, the planet is already hard at work, rewriting the map of the world. It is a reminder that in this universe, nothing is permanent, and that is exactly what makes the story of our planet so endlessly and terrifyingly beautiful. The Earth is still breathing, and it is only just beginning to tell us its story.